Thank you for joining. In this lesson, we will implement implicit model state validation using the ApiController attribute along with various attributes, also unofficially known as the model's constraints. In the previous lesson, I explained the usage of the model state property, which is an instance of the model state dictionary class and serves as a container for errors occurring during model binding and validation. Model state is a property of the abstract controller base class. If the model state needs to be used for explicit model state validation, the controller should not be declared as of the API type, meaning that the ApiController attribute must not be used. In such cases, model validation will be explicit using the model state property. The current code from the previous lesson, containing an if check and the included model state is valid property with a commented ApiController attribute, validates the model explicitly using this if check. In this lesson, let's explore the usage of implicit model validation using the ApiController attribute and various other model attributes. For that, I will uncomment the ApiController attribute. This action means that the part with the if check will not be reached and therefore not triggered by netcore if the model doesn't pass the validation test. Within the model class, we have these attributes, sometimes referred to as constraints. At the end of the lesson, we will explore all the main types of attributes that we can use for model validation. The string length attribute limits the number of characters we can store in a database column. When using the ApiController attribute in ASP.NET Core, it automatically validates the request input against the model attributes specified in our model classes. The ApiController attribute includes automatic model state validation by default. Consequently, when a request is received and mapped to a model, the framework automatically checks the incoming data against the attributes specified in our model class. For instance, the key attribute indicates the primary key for the table in a SQL database. The string length attribute defines the length constraint for string properties in SQL, which will be reflected in the table schema as n_var_char30 for the code property. Additionally, the required attribute ensures that the received data doesn't allow null values. To visualize this more clearly, let's open SQL Server Management Studio. Creating a new table will allow us to define the data type of the column. All the attributes currently used in the model correspond to the data types available in SQL, including allow nulls, which is represented as nullable in our model. When you access the table design, you will notice all the attributes we have applied to the model. In the model, a nullable field marked with a question mark indicates that the allow nullable option is enabled in the database, as seen in this specific case concerning an image property. Conversely, the required attribute implies that if no data is received from the client, like the name property in this instance, an error message will be displayed. In summary, model validation ensures that incoming data complies with the constraints or attributes defined in our model classes before it's committed to the database. This process is pivotal in maintaining data integrity, effectively preventing incorrect or incomplete data from being stored in the database. For more specific error messaging, we can utilize the string format method along with placeholders in curly braces. The 0 placeholder, for instance, can represent the name property since the required attribute decorates this specific property. This method allows for customizing error messages that can provide more contextual information regarding the validation issues. The string length attribute is applied here restricts a string to a maximum of 30 characters for insertion into the database. Similarly, we can establish a minimum length using the minimum length property, setting it to 2. This step would require a minimum of 2 characters and a maximum of 30 characters for the string. In the event that the string length attribute validation fails, we have the option to display a custom error message using the error message property. By utilizing the string format method, we can incorporate the property name this error message relates to. For example, we might write within curly braces 0 needs to be a minimum of 2 and a maximum of 1 characters. So 0 will represent the property itself, which in this case is name. 1 will correspond to the first parameter, set as 30, and the 2 parameter will hold the value assigned to the minimum length property. Once we have completed the implementation of all attributes, we won't test each attribute individually. Instead, at the end of the lesson, we will execute all properties as a single batch. For the next example, let's introduce an additional property named diameter km, set as a double type. We can apply the range attribute to restrict numeric values. In this case, the range should not be less than 9.9 and not exceed 99.99. Additionally, we will use the display attribute to enhance the visual representation of the property name, separating diameter and km. The custom error message will be 0, needs to be a minimum of 1 and a maximum of 2 km. In this case, 0, 1 and 2 reference the name property and both range values. Additionally, as previously discussed in earlier lessons, all these model attributes are akin to route constraints. Understanding route constraints can provide a clearer grasp of model validation. The next property example is email, typed as a string. To validate the email format, we will use the email address attribute. This attribute simplifies validation by instructing the system to verify if the value in the property complies with the standard email format. If the value doesn't match the expected email pattern, let's say missing an @ symbol or not following the basic structure of an email address, the validation for that property will fail. For this, we will set the error message as email format is invalid. This attribute handles all the necessary checks to ensure the email is in the correct format. Additionally, as the email property is required, we will include the required property, specifying an error message that denotes email cannot be blank. Similar to the email address property, let's add a password property. We can replicate the email template, incorporating the required property and changing the property name to password. The error message will remain unchanged for this validation. Following the usual practice, the password entry must be verified. We will duplicate the entire password property, ensuring it includes the required field. The property name will be altered to confirm password, while the required attribute remains unchanged. Next, we will add the compare attribute and specify the property we are comparing it to. In our case, it's password. Additionally, we will include the display name attribute, setting it as confirm the password to enhance the display name. Furthermore, we will modify the error message of the compare attribute to reference 1 and 0 respectively, indicating the password and confirm password properties for the comparison. Introducing the phone property, let's duplicate an existing property, such as the password. We will modify both the attribute and property names to phone and change the property type to int, marking it as nullable. The error message will indicate that the phone number should contain a minimum of 10 digits, allowing only numeric values. For image extension validation, the regex attribute offers a convenient method to implement verification. Using regex, we can efficiently expand the logic for required validations. Additionally, we will include an error message indicating that the file extension must be either JPEG or PNG. Introducing another attribute related to our lesson's subject is active. We will decorate it with the validate never attribute. This attribute instructs the validation system to disregard the property during validation process. Essentially, any validation logic applied to a property decorated with validate never will be ignored. This attribute is commonly used for fields serving internal purposes or properties deemed irrelevant for validation. The isActive property, for instance, can be employed by administrators to activate or deactivate user accounts, not requiring validation. Now let's open Postman. We already have 3 properties set up from the previous lesson. I want to modify or add new ones. We will trigger the newly added model validations and observe the errors when a property is missing. The nullable types won't trigger errors, but all other properties should validate successfully. As you can see, everything works perfectly. If the output needs a different organization beyond what's determined by netcore, we can utilize a convenient abstract validator. As promised, these are the main types of attributes related to model validation. This list is not exhaustive, but you will mainly see these ones presented here. In the next lesson, we will create a custom validation attribute based on a class and implement it in our code. Thanks for watching. If you have any questions or need further assistance, feel free to comment below. Don't forget to hit the like button and subscribe to our channel for more great coding content. Stay updated with the latest videos by ringing the notification bell. Happy coding!